Look up at the night sky. What do you see? Is it just a blanket of darkness? Or do you see the twinkling lights that dot the vast expanse above? Thousands of stars twinkle back at you, each one a distant sun, a beacon of light in the infinite cosmos. Each one is a giant ball of burning gas, just like our sun, radiating energy and light across unimaginable distances. Now, imagine all the stars you can't see, the ones hidden by the vastness of space, obscured by cosmic dust, or simply too far away for our eyes to detect. Billions and billions of them, scattered across the vast expanse we call the universe. Each one a potential solar system, a potential cradle for life. Our universe is a place of incredible beauty, filled with mystery and wonder. Nebulae, the birthplaces of stars, paint the cosmos with vibrant colors and intricate patterns. It's a place where the laws of physics create dazzling nebulae, powerful black holes, and galaxies spiraling through the darkness. These phenomena challenge our understanding and push the boundaries of what we know. It's also a place where we ponder our existence, asking questions about our place in the cosmos. Are we alone? What is our purpose? How did it all begin? Join us on this journey as we explore the wonders of the universe. We'll travel through space and time, uncovering the secrets that lie beyond our planet. From the birth and death of stars to the enigmatic nature of black holes, we'll witness the life cycles of these celestial giants. We'll uncover the secrets of the cosmos, peering through telescopes that bring the distant universe into focus, revealing its hidden wonders. We'll delve into the mysteries of space-time, a concept that revolutionized our understanding of gravity and the universe's fabric. Gravity waves ripple through this fabric, carrying with them the echoes of cosmic events. Get ready to expand your mind and ignite your imagination. The universe is not just out there, it's a part of us, woven into the very fabric of our being. The universe is waiting to be discovered. Its wonders are endless, its mysteries profound. Let's embark on this cosmic journey together and see what we can uncover. Stars, the building blocks of galaxies, are born within massive clouds of gas and dust called nebulae. These nebulae are not just random collections of particles, they are the cradles of creation, where the magic of the universe unfolds. These nebulae are like cosmic nurseries, cradling the ingredients needed for star formation. Within these vast expanses, the raw materials for stars are carefully gathered and nurtured. Imagine a cloud so vast it stretches for light years, filled with hydrogen, helium, and traces of other elements. These elements are the fundamental building blocks of stars, waiting for the right conditions to come together. Gravity is the key player in this stellar drama. It pulls the gas and dust particles towards each other, initiating a slow but inevitable collapse. This gravitational dance is the first step in the birth of a star. As the cloud collapses under its own weight, the center heats up. The particles move closer and closer, and the temperature begins to rise dramatically. Temperatures soar to millions of degrees. This intense heat is crucial, as it sets the stage for the next phase of star formation. This hot, dense core is a protostar on the verge of igniting. It is a young star in its earliest stage, gathering strength and preparing for the moment of ignition. Finally, the pressure and heat at the core become unbearable. The conditions are now perfect for a monumental transformation. Hydrogen atoms fuse together, releasing a tremendous amount of energy. A star is born. This fusion process is the heart of a star's life, providing the energy that will sustain it for millions or even billions of years. This nuclear fusion is the engine that powers stars throughout their lives, bathing their surroundings in light and warmth. The energy radiated from the star illuminates the cosmos, making it a beacon in the vastness of space. From the ashes of dead stars, new stars emerge. The remnants of previous generations of stars provide the material for new stars to form, continuing the cycle of creation and destruction. The cycle of stellar birth and death continues, enriching the universe with the elements essential for life. Each generation of stars contributes to the cosmic tapestry, spreading elements like carbon, oxygen, and iron throughout the galaxy. These elements are the seeds of planets and ultimately, life itself. A star's life is a delicate balance between gravity pulling inward and nuclear fusion pushing outward. This intricate dance of forces determines the star's stability and longevity, creating a cosmic equilibrium that allows stars to shine brightly for millions or even billions of years. The star's mass determines its fate. The more massive a star, the more intense its gravitational pull, and the more fuel it has to burn through. This mass dictates the star's entire life cycle, from its birth in a nebula to its eventual demise. Smaller stars, like our Sun, live for billions of years, steadily fusing hydrogen into helium. These stars are relatively stable, maintaining a consistent output of energy that supports life on surrounding planets. Over time, they slowly convert their hydrogen fuel into helium, a process that can last for up to 10 billion years. Larger, more massive stars burn through their fuel much faster, living for a few million years. These stars are like cosmic fireworks, burning brightly and intensely, but for a much shorter duration. Their massive size and high temperatures accelerate the fusion process, leading to a more rapid consumption of their nuclear fuel. These stellar giants shine brightly, but age quickly. Their rapid aging process means they go through their life stages much faster than smaller stars, evolving from main sequence stars to red giants or supergiants in a relatively short period. As a star nears the end of its life, it runs low on hydrogen. This depletion of hydrogen marks the beginning of the end for the star, as it can no longer sustain the nuclear fusion reactions that have powered it for so long. It starts to fuse helium and other heavier elements, expanding into a red giant. This phase is characterized by the star's outer layers swelling and cooling, giving it a reddish hue. The core contracts and heats up, allowing the fusion of helium into carbon and oxygen. Smaller stars eventually shed their outer layers, forming beautiful planetary nebulae. These nebulae are often intricate and colorful, created by the ejected material interacting with the surrounding interstellar medium. The core that remains is exposed, shining brightly as a white dwarf. The remaining core, a white dwarf, slowly cools down over billions of years. This cooling process is incredibly slow as the white dwarf radiates away its residual heat. Over time, it will fade into a cold, dark remnant known as a black dwarf, although the universe is not old enough for any black dwarfs to exist yet. Massive stars, however, go out with a bang. Their end-of-life stage is marked by a dramatic and violent explosion known as a supernova. They explode as supernovae, the most powerful events in the universe. These explosions release an immense amount of energy, outshining entire galaxies for a brief period. The supernova disperses the star's outer layers into space, creating shock waves that can trigger the formation of new stars. These explosions scatter heavy elements into space, seeding new star formation. The elements created in the supernova enrich the interstellar medium, providing the building blocks for new stars, planets, and even life itself. Supernovae leave behind neutron stars, incredibly dense remnants. These neutron stars are composed almost entirely of neutrons, packed so tightly that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. In some cases, the core collapses into a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. These black holes are the ultimate endpoints for the most massive stars, warping the fabric of space and time around them. Section 4. Black holes, the universe's mystery and majesty. Black holes are among the most fascinating and mysterious objects in the universe. Imagine a region of space-time where gravity is so intense that it warps the fabric of reality. Nothing, not even light, can escape the gravitational pull of a black hole. Black holes form when massive stars die and their cores collapse under their own gravity. As the core collapses, it becomes denser and denser until it shrinks to a point of infinite density called a singularity. The boundary around a black hole is called the event horizon. Once something crosses the event horizon, there's no turning back. It's the point of no return, where gravity reigns supreme. Black holes are not cosmic vacuum cleaners. They don't suck in everything around them. However, if an object gets too close, it will be pulled in by the black hole's immense gravity. Section 5. Spacetime, the fabric of reality. Imagine a trampoline stretched taut. This is a simple way to visualize spacetime, the fabric of our universe. Albert Einstein's theory of general relativity revolutionized our understanding of gravity by introducing this concept. Spacetime is not just empty space. It's a four-dimensional fabric woven together by space and time. Massive objects like stars and planets create curves in this fabric, just like a bowling ball placed on the trampoline. These curves are what we experience as gravity. Imagine rolling a marble on the trampoline. It will curve around the bowling ball, attracted by the dip it creates. Similarly, objects in space move along the curves in space-time created by massive objects. The more massive an object, the more it warps space-time. Black holes, with their immense gravity, create the most extreme distortions in the fabric of space-time. Section 6. The Expanding Universe. A Journey Through Time. Our universe is not static, it's expanding. Edwin Hubble's observations in the 1920s revolutionized our understanding of the cosmos. He discovered that galaxies are moving away from each other, and the farther away they are, the faster they're receding. Imagine baking a loaf of raisin bread. As the bread rises, the raisins move farther apart. Similarly, the space between galaxies is stretching, causing them to move away from each other. This expansion means the universe was once much smaller and denser. If we could rewind the cosmic clock, we'd reach a point where everything was concentrated in an extremely hot, dense state, the Big Bang. The Big Bang, which occurred about 13.8 billion years ago, marks the beginning of our universe's expansion. It's not an explosion in space, but rather the expansion of space itself.